Okay, so my name is Mandy Wade. I am a developer advocate for Google Cloud Platform. Thank you for coming today. Thank you for coming to the Google for Mobile event. And thank you for coming to this talk, giving your time to come to this talk. Developer advocates on Google Cloud Platform. And we're going to talk about Google Cloud Platform. This is an introduction to Google Cloud Platform. So basically, we go back in time. And yes, the cloud of today shares a lot of similarities with the private data centers and the co-location facilities of the past, where your team spends a lot of time thinking about servers, memory, network connections, and storage. And while your team isn't actually touching that physical equipment, they have to manage, monitor, and care for virtualized versions of the same equipment. So we used to use this kind of cloud inside Google up until about 10 years ago. Google's business was built upon using the same virtualized data centers that people call cloud today. But we realized our business really couldn't scale fast enough unless we reduced the complexity of that model. We had to invent everything about how we built, deployed, and ran software on our cloud to be able to manage that complexity. And today's cloud, we effectively call the third wave cloud, a combination of automated services and scalable data. Today, inside Google, developers work on products such as YouTube, Gmail, Google Maps, but they never write deployment scripts. Their code is pushed into production multiple times a day. Our engineers don't spin up servers, but their applications serve millions of users each month, and each minute even. They use shared databases. They don't use shared databases. They write failover scripts or patch software stacks. And yet their software is some of the most resilient and secure software ever created. This approach lets our developers write code without thinking about infrastructure. So Google Cloud Platform actually effectively gives you access to the productized versions of these services. And this is available via managed services. They give you access to the same scalable data platform. Consequently, Google Cloud Platform customers do a lot less unproductive work. It's an actual global, elastic, on-demand set of services. It doesn't require you to figure out how to build it and make it work. It's not about having enough machines, cables, and disks. It's effectively about having the right abstractions that allow you to simplify complexity. So it's way better to actually show you how the value of Google Cloud Platform than actually talk about it. And in the Google I/O talk that we did for this particular set of slides, we did live coding demo and showed an application in production. And so to do this, I'm going to show you how we built the back-end service for the next mobile hit, which is called Photo Scavenger Hunt. And if you'd like to play along during this talk with the application, you can find the application on the Google Play Store. And you just search for Cloud Photo Scavenger Hunt, and you'll be able to find the application. So what does the application do? So with Photo Scavenger Hunt, you're effectively given 4 clues, 4 different clues every time, and what to find in the real world. So in this case, we would ask you to go out and find coffee, to find umbrella, to find glasses, and to find cactus. You take pictures of these things with your camera on your mobile phone, and the application tells you what it finds in the picture using the Cloud Vision API. If what it finds matches the clue, then you move on to the next clue. If you get all 4 correct, you win the game. Okay? So you should try this out. It's on the Play Store. The architecture of the application is very simple. The mobile client is available for iOS and for Android, and this connects to a Nodejs back-end service, a back-end game service, effectively. This generates the clues and returns them to the client. So here we see the clues being displayed on the client. When the user answers a clue with an image that they upload, this is uploaded to Google Cloud Storage here. And then a call is made to the Cloud Vision API, which Kaz Sato just talked about. And we send a call to the Cloud Vision API with the path to the image. The Cloud Vision API reads the image, and then returns back the set of labels that it's found back to the game server. This will then tell the user whether they got the question right or wrong. Game state is stored within the Google Cloud Datastore. So this is a data store for game state. And this could be the labels and also for user level state as well. So let's talk about how we develop this application and effectively going from productivity to production. So development is fairly straightforward. We're going to start off development and run the backend application locally initially. The app, as I said, is a standard Node.js application, and we'll make use of 3 specific Google Cloud Platform services. These are the Cloud Vision API, Google Cloud Storage, and Google Cloud Datastore. To greatly simplify development and to allow access to these Google Cloud Platform services, we're going to make use of the Google Cloud Client Library for Node.js. Google Cloud Platform offers these libraries for many different programming languages, most of the popular programming languages. And these have been handcrafted to provide a very familiar developer experience to all developers. In this case, to Node.js developers specifically. But it's the same for Java developers and C# developers, Python, etc. So let's look at the 3 cloud platform services that we've used for Photo Scavenger Hunt. The first one is Google Cloud Storage. And Google Cloud Storage is an object store for very large amounts of unstructured data, any size of object and any number of objects. Objects such as images. In this case, that's perfect. We can use this for images and other forms of binary data, up to terabytes per object. Google Cloud Storage has different levels of storage too. These all offer the same durability, but what's known as DRA, durable reduced availability, and nearline effectively trade off cost against reduced availability, making them ideal for archival purposes. Cloud storage offers strong read-after-write consistency, and the data is encrypted at rest. So in Photo Scavenger Hunt, we're going to use Google Cloud Storage to store the images that are uploaded from the application. So Cloud Vision API is effectively used for analyzing and classifying those images. For those of you who were at the previous talk, you would have seen an introduction to Cloud Vision API. I'm going to give you a quick overview of it. But basically, what it does is within images, Cloud Vision API can detect facial expressions, it can detect logos, it can find objects. This is called label detection, which we're going to make use of. It can detect inappropriate content, it can OCR documents, and it can also do landmark detection. You specify which features you want to use and the image, and it will return a JSON object that gives you the results of that classification of that image. And again, the previous talk went into more detail on this. So, but here's a very quick example from my photo collection. I was in Japan for the last 2 weeks, and this is the Shinkansen bullet train. The bullet train looks more like a duck than a train, to me anyway, or a swan, a duck or a swan. But the Cloud Vision API recognizes it as a high-speed rail train. Transport here, high-speed rail, vehicle, train. So it doesn't look very much like a train, but Cloud Vision API recognizes it as high-speed rail. So therefore, this is the main component of the application. In Photo Scavenger Hunt, we use Cloud Vision API to look for objects within the photos and the images that users send up to the game backend server. But I also look for inappropriate content too. The Cloud Data Store was built on top of a Google internal service called Bigtable, and it was originally used with Google App Engine. Hopefully some of you are familiar with Google App Engine. It's now available as a standalone API and data service. It's a NoSQL database, and it removes the need for you to have to worry about managing infrastructure. And that includes things like replication, sharding, and scaling. You don't have to worry about those things. Applications that run on App Engine have the potential to scale massively. Think something like Snapchat. So Snapchat runs on App Engine today and has to scale massively. And so you need a data service at the back end, effectively, to scale automatically in exactly the same way that App Engine will scale itself. And so that is the cloud data store, no SQL-based data store. In Photo Scavenger Hunt, we use Cloud Data Store to store the game state. That stores the labels from the images and also information about the users interacting with the game. In order to simplify development, we will use the Google Cloud Client Library, and specifically the Google Cloud Client Library for Node.js. Versions of this library are available for all of the popular programming languages. They are built by hand on top of automatically generated libraries, and they provide a very familiar experience to developers developing in the language of their choice. So if you're a Node.js developer, this will seem extremely familiar to you. Here's an example of what that looks like, some of the code from the actual game itself. So this is Node.js code. Apologies for those who don't code in Node.js or JavaScript. Here what we do is we install some dependencies up here, and then here we install or pull in, we've already installed this using an NPM as an NPM package. We pull in gcloud, require gcloud. And so effectively we're requiring the client library. We can then use the gcloud object to access the different services. So in this case, we can access cloud storage. gcloud.storage gives us access to storage. And from that, we can create a bucket. We've used an environment variable here to specify the name of the bucket, but we call storage.bucket, and it gives us the name of the bucket. And finally, down here, we access the Cloud Vision API. gcloud.vision will give us an object by which we can make calls to the Cloud Vision API. So then, once we have those objects in place, we can add functionality to our code. Here we define a specific endpoint for Photo Scavenger Hunt backend. This is the endpoint for uploading images. So it's API/game, game ID, and we upload an image to this location. We can then make calls to bucket.upload, passing in some details about the file we've just uploaded, and that will just store the file in Google Cloud Storage. And then for vision, we can do vision.annotate, and we can pass in the file path as a set of arguments. We can pass in a callback function. And the vision API will then return back the results. And effectively, that's all you need to do to be able to make calls to these services. Very, very simple. So let's talk about deployment. That's the application development. So the next part is, first you initially struggle to scale your environment, and next everybody just go into the ship party. So in the first and second wave of computing, where we had these co-location facilities and we had data centers, deploying apps effectively involved working with infrastructure and deploying and managing your software stacks. In the third wave, you simply write your application code and deploy it to a fully managed service. So there's no need to worry about building software stacks or managing infrastructure. For running Photo Scavenger Hunt backend, we'll run this on Google App Engine. App Engine is a fully managed service, and it will effectively run your application code for you. You focus on writing your code, and we manage the software stack. We manage patching the software stack, and we manage the infrastructure that runs it. It supports Java 7, Java 8, Python 2.7, 3, and Python 3, Node.js, PHP, and Golang. So you can pretty much run any language on Google App Engine. There's also a vast array of CPU and memory configurations. It provides this very, very simple code-to-node deployment option. And you can also extend this to support any other environment. So extensible runtime environment, you can bring your own runtime, including things like Haskell, Scala, .NET, etc. Okay, so you can run pretty much anything on Google App Engine. And we'll manage the entire thing for you. While the application uses some Google Cloud Storage, Google Cloud services, we could have actually chosen to use other services from other providers, particularly for label detection and for storage. Or we could have effectively built our own, or even provided our own storage. The application is a plain Node.js application and can be run with very familiar Node.js tools, and can also be deployed anywhere where we can run a Node.js application. That could be to Heroku, it could be to any Cloud Foundry, any other service that could run this. But ultimately, we can do our development testing locally using tools such as NodeMon. And here we're running NodeMon app.js, and we're monitoring the running application. Once we finish development, we can deploy to Google App Engine. So here we can deploy to Google App Engine using the cloud, the G-Cloud tool, which we'll talk about shortly. So the G-Cloud tool here is the Google Cloud Platform command line tool. When we run G-Cloud app deploy, it creates a Docker file based on your application code and based on a very, very simple configuration file that you pass into it. This is all passed through a container build service. The container image is built in the cloud and then stored in a private image repository for you. This is within your Google Cloud Platform project. The container image can then be run anywhere where you can run a container. And that could be on Kubernetes or Google Container Engine. It could be in Docker running on your laptop. It could be running on Docker running on Amazon, or any way where you can run effectively a Docker application. So one option, as we mentioned, is Kubernetes. How many of you have heard of Kubernetes? Okay, not many of you, a few of you. Excellent, a couple of you, good. So Kubernetes is really about an example of the evolution towards that third wave of computing. It's easy to evolve live services to evolve and deploy live services with Kubernetes. This is a highly popular container orchestration system that runs, manages, and orchestrates your container-based applications for you. Google was heavily involved in the early development of containers, contributing both C groups and namespaces back to the Linux kernel. The Google internal system, that's known as Borg, some of you may have heard of it, this runs processes across multiple large clusters of machines. And today, we launch something like 2 billion containers per week. We've taken the best of Borg and used it as a foundation for Kubernetes. So Kubernetes takes groups of virtual or physical machines and aggregates them together into clusters. It's a smart scheduling service that takes care of running your containers within the cluster. As of 1.3, Kubernetes 1.3, we even support multiple clusters. So this can be on-premise machines, it could be cloud availability zones, or it could also be on different cloud providers. So Kubernetes ultimately supports having applications or components of applications running on different cloud providers. So part of it could be running on Google Cloud Platform, part of it could be running on-premise, part of it could be running on Amazon, EC2, or on Microsoft Azure. Ultimately, this is the key point, Kubernetes and container orchestration in general is about managing applications and not having to manage and worry about machines. So let's talk about a new pattern of computing that's called cloud-native computing. Applications can be developed on a cloud platform, then deployed to different clouds where supporting software stacks will help them run at scale. This is the model that we've developed internally over the last decade or so. But the patterns are not unique to Google. We've seen the co-evolution of these capabilities wherever companies have attempted to tackle internet scale type computing problems. So things like containers and container frameworks, including things like Kubernetes, and microservices as well. So finally in this talk, let's look at diagnostics. We want you to spend less time diagnosing and more time developing. So a survey, a Google-run survey of external developers revealed that 31% of developers spend their time debugging and reproducing and fixing issues in production code, effectively. This kind of debugging of production services is very time critical, and it has very high stakes. Your application may be down. It may be down right now, and you're having to debug that code in a live environment. There's also lots and lots of data and very little in the way of information. Potentially an imperfect understanding of how the system works also gets in the way. So what we have at Google, and what we're providing as part of this third wave cloud, is the ability to greatly reduce that overhead by reducing the guesswork, speeding up the process of iteration, and also providing much greater system transparency. And we do this through tools such as trace, error reporting, and the product debugger. So Google Stackdriver, we have this thing called Google Stackdriver. It's effectively a product suite. Google Stackdriver provides powerful monitoring, login, and diagnostics to production applications, not just to development and test, but to production applications. So distributed tracing for constantly monitoring and providing insight into where your application is spending its time. We know that applications make calls to other services. Our application here makes calls to cloud storage, to Cloud Vision, and to Cloud Datastore. Cloud Trace can give you information about how long it spends in each of those calls and allow you to optimize. Error reporting effectively provides intelligent analysis of log files and service issues, and it also provides a very centralized way of managing all of your application log data. This can provide alerting, it can provide pager duty access, sending emails out to people when things go wrong. And also over here we have the product debugger. And the product debugger effectively allows you to dynamically inspect the state of your running service in production, while it's in production. So you can set breakpoints. Well, we used to call them breakpoints, but in this case we call them snapshots. We won't stop the running application. The application will continue to run, but we can set a snapshot so that when the code hits that snapshot, we can analyze the state of the system at that point in time. That means we can examine call stacks, and we can also watch variables and look at the values of variables at that snapshot. This is really, really useful for debugging, particularly in production, where you may not want to take or be able to take the application down, and you may not be able to recreate a specific problem. So, to wrap up, what we've talked about today in this session is how Google Cloud Platform is a different kind of cloud. And it may potentially be better. You should try it out. If you're using Amazon EC2 or other cloud platform providers, you should certainly look at Google Cloud Platform for building back-end services to all of these other great things that people are talking about today. It also provides a very productive local development experience. We've seen how we can develop applications using standard tools, things like NPM, Node, NodeMon. That's the same for all languages. So we provide a very productive local development experience. It also allows very simplified programmatic access to all of these very good and very excellent Google Cloud Platform services. Things like Datastore, cloud storage, Cloud Vision API. But we also have many other services as well. Google BigQuery, Google Dataproc for running Hadoop, managed Hadoop. Many, many other services you're given access to via this simplified programmatic access. Also, we've looked at deployment to App Engine, and we've also talked about Kubernetes. So this talk was originally given at Google I/O by myself and Brad Abrahams. This talk online contains live coding demos. So if you want to see the live demos themselves, I didn't want to do them here because of translation. They're all in this talk here. You go to bit.ly IO 2016-1 lap, and that's the complete talk. So please have a look at that. If you have any questions or comments, please feel free to comment on there, and I will do my best to answer your questions. So basically, thank you for your time. If you want to try this out, go to cloud.google.com/developers or cloud.google.com on its own, and there you'll be able to sign up for a free trial. If you already have a project, please use it. If you don't, you can sign up for a free trial. So that's it. So thank you very much. Thank you.